In Module 5, we're going to begin working with rational expressions. So today's goal is section 5.1, where we are going to learn what the heck a rational expression even is. So let's dig into these notes. A rational expression, you ready? Is a fraction, a ratio, where you have a polynomial on the top and a polynomial on the bottom. So a polynomial on the top, polynomial on the bottom. So it's a fraction with polynomial on the top, the numerator, and bottom. Now they could be really fancy polynomials, or they could be real simple ones like the number 5. You know, that's technically a polynomial. It's just a constant function, but that could be part of this as well. The domain. Remember we've talked a little bit about domain throughout the year. Now, domain is what x values can be used in any function. So, for example, most of the functions we've been looking at this year were not very limited. I mean, we could plug just about anything in. For example, let me change this here. Y equals x squared was a quadratic, and you know what? You could plug any old x value you want into that, and you won't have any troubles at all. You'll be able to get a y. So we would say the domain is all real numbers. It's what's allowed to be plugged in. The domain would be all real numbers. Now let me show you something here. If I change this to the square root function, now if I tried to plug negatives in, I would get imaginary numbers. So those numbers are not allowed to go into this function if we want to keep it real here. So the domain would be 0 and higher. 0 and higher. So we would say the domain is, I'm going to use that interval notation. Remember, we use a bracket when we're allowed to include, or when we need to include 0, and then to infinity. So we would say that's the domain on that because we understand only 0 and higher can go in. So that's the concept of domain, and that's going to be an important one when you're talking about rational expressions. So the domain is, it's the domain of the numerator unioned or combined with the denominator, denominator, but also the denominator can't be 0. We have to watch out for that. The denominator cannot be 0 when we're talking about the domain of a rational expression. So remember the definition of a polynomial before we do these next two examples. A polynomial is a mixture of letters, numbers, and exponents. Remember, we can't have two, like the x and y can't be multiplied together. We can't have an x under a square root. We can't have an x in an exponent and still call it a polynomial. So we're going to try to keep things, quote, simple. And a rational expression has to be a polynomial divided by a polynomial. So the question says, determine if this is a rational expression as defined by what we've talked about. And it would be yes, because this is a trinomial, degree 2, right? It's called a quadratic. And we're dividing by a binomial, which is degree 1. Okay, we can do that. That's called a rational expression, what you're looking at here. Now, this example, however, this is a fraction, and we've got an expression on the top and the bottom. However, we're not allowed to have the variable under the square root and still call it a rational expression. So, no, this is not stuff we're going to be dealing with in this chapter, in this particular, okay? I do also, well, let's move on. Okay. Determine the values that are excluded. Now, what does excluded mean? Excluded means we need to leave them out. I like to call them my problem children. They're numbers that cause the denominator to be 0, because we said up here the denominator on these things cannot be 0. So let's look at this example here. This is okay for the numerator to be 0. That's fine. But this expression, x plus 1, is not allowed to be 0 because that would cause a divide by 0 error. And in math, that is forbidden. Okay? So we're not allowed to have the denominator 0. So the question is, determine what values might create this problem. Well, that's pretty easy. We just minus 1 on both sides. We get x is not allowed to be negative 1. That's all we had to do there. So in this particular problem, you literally only focus on the denominator and figure out, you can solve a little equation like I did, what causes that to be 0. So let's go to example D here. What causes only the denominator? Don't worry about the numerator because the numerator is allowed to be 0. 0 divided by anything is actually 0, so that's allowed. X is allowed to be 3, no problem there. But let's look at the denominator. What causes this to be 0? Well, you know what? That looks like some of those quadratic equations that we worked hard to learn how to solve. Well, I'm going to use the factoring method. X minus 3, x minus 2, we're not allowed to have that equal to 0, so x is not allowed to be 2, and x is not allowed to be 3. You see how that works? Because that will cause the denominator to be 0, and that is not allowed. So we had to identify the problem children. You probably know some, right? Identify the problem children, those x values that cause the denominator to be 0. Let's keep moving on. There's another skill for you, and it's called simplifying. And all we're going to be doing is reducing fractions. So let me write that down. We're going to be reducing fractions. We're going to cancel stuff. We're going to cancel whatever we can cancel. So let's start with this one. The first thing I'm going to do is factor it. I'm going to factor it. So on the top, I see that I could take out a 4. So let's do that. 4 comes out, and I'm left with x minus 2. That's the top. And then on the bottom, I can divide them both by 10. So I'm going to factor that out. X minus 2. Now what happens when in a fraction, when you have the same thing on the top and bottom, and I see that here, we have the number 2 less than x on the top and bottom. So what happens? Cancel. They cancel. Completely cancel. So we're left with 4/10, which, by the way, is 2 times 2 on the top and 2 times 5 on the bottom. So once again, this fraction reduces. Those 2's could be thought to cancel, and we get 2/5 is the fully reduced fraction here. Now, stay with me here. You ready? This expression, no matter what you plug in a million, plug in 3, plug in -5, your calculator will say 0.4 every time, no matter what you plug in. This particular problem, x doesn't matter, because all the x's canceled away when we reduced it. That tells us that the rational expression here is actually just a constant. This doesn't happen very often, but it is. Anything you plug into here, 10, -10, you're going to get 0.4 out of your calculator. Let's do another one reducing away, because this is so much fun, isn't it? You always want to factor first. So let's write that down into your notes. Factor first. fix that I. Not really, but you know what I mean. So here we go. On the top, I'm going to factor out a 2, x squared minus 9, all over x minus 9. Now, the 9's don't cancel. The x's don't cancel yet, but we can do more factoring on the top. That's 2, x plus 3, x minus 3. Remember that difference of squares. Okay. Now, is there anything on the top that matches the bottom? Anything at all? No, there's not. So this was fully simplified, actually. There was nothing we could do. Now, it is nice to have this in factored form, to have that 2 pulled out. But there's actually nothing else that can be done there. Let's move on to another one. This looks kind of crazy, right? Generally, students don't like fractions. So when we throw this in your lap, oh my goodness, this is kind of crazy. We're going to factor first. And I'm going to pull a 4 out of the top because they're all divisible by 4, and that makes my life a lot easier. All the numbers get a lot smaller. And well, let's see, that would be 21. I like the number 21. On the bottom, I'm going to go ahead and reverse FOIL that while I'm at it here. That would be x minus 7 and x plus 2 on the bottom. Now the top, we can take that further, so let's keep going. On the top, x minus 7, x plus 3. And on the bottom, remember we already got x minus 7 and x plus 2. Now step back a moment. Do you see anything on the top, a number on the top that matches the bottom? Now don't just say 7 or negative 7. It's actually this entire binomial. This entire binomial, 7 less than x, will cancel with the denominator binomial. So the final answer here, by the way, there's nothing else then. That's it. 4 times the quantity, x plus 3, all over x plus 2. And no, those x's cannot cancel because they are part of a binomial. Like this is part of a number 2 more than x. Notice I try to say that real fast. 2 more than x, because it's one number. You can't just pick away the x from that and cancel it with the x on the top. This would be the answer. Factor and cancel. Number 2, or letter D here, we're going to have to factor. So let's give that a try. On the bottom, it would be, that's a difference of squares. You need to spot those. 2x plus 3, 2x minus 3. That was easy. And then on the top, I know it's going to be 2x and x, and I know I have to make 3. So it's got to be 3 and 1. And if I put the 3 here and the 1 here, do you notice that I get 6 and 1? And 6 minus 1 makes 5. This is all the stuff that goes through my head when I'm trying to sort that out. Now, I did show you an algorithm to do that also, but to me, this one was easy enough that I was able to actually sort of guess and check and figure this out. So let me just double check that I did that right, because I'm seeing nothing cancels, which seems kind of strange, but 2x, oh, no, I did make a mistake. Oh my goodness. I did make a mistake. This was not right. It's 3 and 1. However, I need to put the 3 here and the 1 here and make them both negative, because I didn't notice that this 3 was positive. So now a negative times a negative makes a positive. And I get -2 and -3, and those combine to be -5. So I'm sure you were screaming at your computer screen or your phone, right, just now. So I apologize profusely. Does anything cancel? Do you notice anything that matches on the top and bottom? Yes. This 2x minus 3 and this 2x minus 3 cancels. The answer is x minus 1 over 2x plus 3. I'm going to circle it. That's my answer. How cool is that? We just simplified what's called a rational expression. We have one more problem to do. Now this is called a monomial over a monomial, and we actually did these earlier in the year. Remember, you subtracted the exponents. You could also think about numbers canceling. So that's what I'm going to do here. I'm going to rewrite this like this. And then on the bottom, watch what I do. I'm trying to show you the canceling, so I'm trying to focus on that primarily. And the y to the 12th could be thought of as y to the 7th times y to the 5th. Because remember, when you multiply powers, you add exponents. 7 plus 5 is 12. Why am I showing it this way? Why did I do that? Because this 7 cancels that 7. It's just poof, it's gone. This x cancels that x, it's gone. That 3 cancels that 3. And I'm left with my final answer. X on the top, 9 on the bottom, and a y to the 5th on the bottom. So instead of subtracting exponents, you can also think about variables or factors canceling. They can even just be numbers that are canceling. That's it to this section. We covered what on earth a rational expression is. It's a ratio of two polynomials, and how to simplify them. We also talked about domain. Remember, the denominator cannot be 0. That's really important, and that's going to come back all chapter about how that denominator cannot be 0, so we need to stay away from those numbers when we're working with these. All right, hopefully this was helpful. You're ready to dig into the assignment. Good luck.